Take a minute to practice your synthetic division on the warm-up problem and then check your answer. Be sure to pause this video while you work out the solution. Take note that when you did the synthetic division, you ended up with 0 at the end. That means that there is no remainder. What that tells us is that x minus 4 is actually a factor of the original polynomial 2x cubed minus 3x squared minus 18x minus 8. So our answer that we got when we divided the 2x squared plus 5x plus 2 is the other factor that goes into it evenly. The remainder theorem that we just worked on said that if I want to divide by x minus k, it's the same idea as evaluating the function at k, so f of k. And whatever f of k turned out to be equal to in the very end, that last number that you get, that's the remainder. So then we were able to rewrite a new polynomial using one exponent lower than what we started off with, like we did in class today. The factor theorem says that a polynomial f of x has a factor x minus k if and only if f of k is equal to 0. In other words, if our remainder turns out to be equal to 0, it means x minus k went in evenly. Take a look at the problem that we have here. They tell us the k value, so the negative 3 is what's going to go on the outside. 2, 11, 18, 9, double check, make sure you don't need to account for any zeros in there. Bring down your 2, multiply, negative 6, add to get 5. Negative 15, add, you get 3, you get a negative 9, and you get 0, which we expected to get. They told us if we evaluated at negative 3, we get a remainder of 0. But the important part now comes in here. It tells us that if I take x minus k, which k in this case is negative 3, that I would multiply that times 2x squared plus 5x plus 3 in order to get the original f of x. So x plus 3 times, oh wait, let's take a look at this. If I use 2 and 1 and 3 and 1, and I cross multiply here, I get 2, I get 3. Those can add to give me 5. So I can factor this trinomial even further. I would have 2x plus 3 and an x plus 1. So we're using our synthetic substitution, our synthetic division, as a means of factoring this problem and getting our solution to factoring. In the next example, they're again telling us f of k is equal to 0, f of negative 4. They're telling us exactly what to put on the outside. Inside we've got a 3, a 13, a 2, and a negative 8. So we have 3, multiply, negative 12. Add to get 1, multiply, negative 4, that's going to give us a negative 2, 8, and 0. Good, that's a nice checkpoint because we had a remainder of 0 like we were supposed to have. Then I would take x minus k, so it becomes an x plus 4 inside the parentheses. And now this stuff here that we just got tells us our other polynomial, 3x squared plus x minus 2. And again, I would check to see, can I factor this further? So let's try a 3 and a 1. Let's try a 2 and a 1. If I cross multiply 3, if I cross multiply a 2, I need to be able to subtract and get 1. 1's got to be positive, 3 must be positive, 2 must be negative. So we then can factor down to x plus 4 times 3x minus 2 times x plus 1. In this problem, they're telling us what one of the zeros is going to be, and we need to find the other zeros. Well, remember, zeros are solutions. And that's where we said something like x minus k is equal to 0, and then we solved to get x equals k. Well, they're telling us x is equal to 2 in this case. So k is equal to 2. That's what we're going to use when we do our synthetic division. So if we use 2 on the outside, we're going to have 1, negative 2, negative 9, 18. What do you think is going to happen when we do this if 2 is a 0? Well, let's see. If I bring down my 1, I multiply, we get 2. Oh, those cancel out. I get 0. So 2 times 0, we get 0. A negative 9, we multiply, we get negative 18. Negative 18 and a positive 18 is 0. So here's our remainder, which makes sense because 2 goes in evenly, right? That x minus 2 works evenly as a factor. So that tells us that x minus 2 times x squared, hey, check this out. We get a 0 here for the x term, minus 9. These are our two factors. But this piece can be factored down further, and we don't even want to care about this one right now because that's counted up top. So we just want the other zeros. So let's take x squared minus 9, set that equal to 0. That's x plus 3 times x minus 3. So x is going to be equal to, this will give us a negative 3 from this one and a positive 3 plus or minus 3. These are our other zeros. Same scenario, we're given one of our zeros to the function. We need to find the other one. So when we're done, we're not going to list the negative 5 again because that would mean that we have negative 5 and another negative 5 as zeros. Okay, here's our setup we're going to use for our synthetic substitution. We bring down the 1, multiply, we get negative 5, that's a 1. We get negative 5 again, and we're at negative 2. Negative 2 times negative 5 gives us a 10, and we get 0. Nice checkpoint for us. We should get zeros here. So our other polynomial that we're dealing with is x squared plus x minus 2. If we want to see what this results in, we need to see if we can factor this. Are there two numbers that multiply to give you a 2, that subtract to give you a 1? So we're going to have x plus 2 and an x minus 1. So from this, we get zeros of negative 2 and a positive 1. Again, I did not list my negative 5 because it only asked me for the other zeros, not all zeros. Take a few minutes to try these two problems on your own. Write them down, pause the video, and when we come back, we'll give you the solutions. Okay, here are your two solutions for number 5 and number 6. If you did not get these, please go back, try them again, see where your mistakes may be. And if you have any questions, please put a reply on this post on Edmodo so that I can help you out.